Good morning to everyone. All of you can able to hear my voice?
Yes,
Yes,
sir.
sir.
Good morning.
Good morning. So all of you can able to view the whiteboard?
Yes, sir.
Okay. Uh, Today I'm going to start with the next topic that is called as a decoder. Okay. Okay, it is one of the combinational circuit. It is combination. It is one of the combinations. It is a combinational circuit. So what is the duty of the decoder means? It convert binary information, convert the binary information from and inputs and input lines to maximum of 2 power n unique output, maximum of 2 power n unique output lines. Okay, so what I dictate, that can be represented in diagrammatic way. For example, so already you know that. For example, suppose what is the value of 2 power 0? The 2 power 0 is nothing but 1. What is about 2 power 2? 2 power 2 is 2. What about 2 power 2? 4. 2 power 3? 8. What about 2 power 4? There is a 16. What about 2 power 5? There is nothing but 32. Okay, what I am trying to say that suppose your input is, suppose you are going to provide input. Okay, the suppose n equal to 2 means, n equal to 2 means there is an input for decoder. So what it going to does means, okay, it going to generate, it going to suppose how we are going to denote the decoder means, such a way that we are going to denote n into 2 power n. So what is the meaning of n means? That is called as a input. What is the meaning of 2 power n means? That is output of decoder. Okay. Suppose n value you are going to providing as an input for the decoder. So what it going to does? What it going to does? It going to produce output as, it going to produce output as 2 power n. 2 power n. For example, n equal to 2. For example, in our case, n equal to 2. So what is the output of the decoder? The output of the decoder is, the output of the decoder is 4. It going to generate 4 output. I'm going to providing naming for those output, namely called y0, y1, y2, y3. Okay. Suppose I'm taking the decoder. Okay, this is a decoder. The now the n value is 3. So what about the output? The now the n value equal to 3, namely called x. Okay, namely called x, y is z. What about the output? So it's going to generate the 8 output from y0 to y7. Okay, so n is called as an input. 2 power n is called as output. Okay, there is a specification of decoder. Okay, there is a specification of decoder. Okay, do you have any queries? Do you have any queries? What is a decoder?
No, sir.
So next, we will see how we are going to implement the decoder, and then what are the specifications are there. Let's see one by one. Okay, normally the decoder implemented using two ways. One is decoder. Their decoder. What happened when how they are going to implement the decoder means the decoder implement with enable input. Okay. Again, that enable input is divided into two categories. One is active high input, another one is active low input. Active low input. I will tell you what is the meaning of that. So already you know that what is the specification of decoder. So what it's going to do? It going to take input as AND bits. Okay, it's going to take input as AND bit. What happened? It's going to generate the output as 2 power n. Okay, the output as 2 power n. Okay, the output as 2 power n. Okay, for example, some cases what happen in the circuit, if we consider any circuit diagram, more than one decoders are available. So at a time, I want to enable only one decoder. Okay, such thing how we are going to achieve means make use of that enabling. Okay, so this is called as a they called as a E. So what is the meaning of E means? We are going to provide certain input value for E. Suppose I will tell you what is a active high, what is a active low. First case, what I'm going to do, I'm going to take it for active high input. So what is the meaning of active high input means? So I'm taking the encoder. For example, n equal to 2. So n equal to 2 means it's going to take input as 2 bits. What happens? It's going to generate output as 4 bits. Okay, the outputs I'm going to denote using y variable. Okay. So what is the meaning of active high in the sense? Okay. So here what is the function? Here what happen? I'm going to provide a enable input. So what it going to does means that E is associated with the two values. That E is associated with the two values. One is 1, another one is 0. So whenever suppose you are going to provide input as a 1 in the sense, what happen? It's going to enable the circuit. What happen? It's going to enable the circuit. Suppose you are going to provide input as 0, what happen? Okay, no operation. It does not perform any operation. Okay, what is the meaning that it disables that decoder. Okay, so what happened? It's going to suppose I'm going to provide input as 1 in the sense what happened? It's going to enable that circuit. What happened? It turn on your circuit. Suppose you are going to provide input equal to 0 in the sense what happened? It turn off your circuit. So that is the functionality of active high input. So what is the meaning of active low in the sense? Active low in the sense it is just opposite to active high. Active low input means active low input in the sense. Similarly, I'm going to take same encoder that is nothing but n equal to 2. So it's going to take 2 input from the user and then it's going to generate 4 output. Okay, namely called y0, y1, y2 and then y3. Okay, so n into 2 power n. Okay, here what we are going to do, that enable circuit how I'm going to implement means make use of active low input. So active low input in the sense what happened? Okay, here some bubbles is there. Here what happened? Some bubbles is there. So compare with previous one. Here there is no bubbles. Here some bubbles is there. Okay, it is also what happened? It associated with the two values. One is 0, another one is 1. Suppose I am a user, I am going to provide input as 0 in the sense what happened? It's going to enable the circuit. It's going to enable the circuit. Suppose I'm a user, I'm going to provide the input as 0, 1 in the sense what happened? No operation. So what is the meaning that it disable the what happened? It switch off your decoder. Okay, rather it's called as a disable your decoder. Okay, so what is the use of enable input in the sense? Suppose if any, for example, if we consider your processor, it associated with n number of decoder. At a time, I want to enable only one decoder at a time in the sense how you are going to do that means make use of that enable input. Okay, make use of that enable input. Okay, do you have any queries? Do you have any queries?
No, sir.
Okay, so I'm going to take, let's see, uh, how we are going to implement 2 by 4 in, decoder, how we are going to implement 3 by 8 in decoder. Okay, let's see one by one. First, what happened? I'm going to take 2 by 4 decoder. What happened? First, I'm going to take 2 by 4 decoder. So name itself you can easily understand. Understood that 2 is and 4. What is the meaning there? 2 is nothing but input and 4 is nothing but output. Okay, similarly. So what is the meaning of 3 by 8? 3 by 8 decoder, what is the meaning there? So meaning is 3 is input and 8 is output. This is the input and this one is output. So what about 4 into 16 decoder? What is the meaning is, so 4 variable as a input and then it's going to generate output as, it's going to generate output as 16 values. That is the meaning is meaning. Okay, let's see one by one. First, I'm going to begin with 2 by 4 decoder. Okay, so how the circuit specification should be appear? Okay, going to take the two input x5. This is a decoder. Okay, how we are going to denote n into 2 power n. N into 2 power n. Okay, whenever it's going to take input as a two variable, what happen? It's going to generate output as 4 value as output. So for that, what happen? I'm going to draw the truth table. Okay. So what I previously tell that the diagrammatic specification, okay, that can be written as the truth table. Okay. So what are the inputs are the x, y. So what are the outputs are the, so y0, y1, y2, y3. Okay, this is a two variable function. So two variable means how many number of combinations are available? 0, 0, 0, 1, 1, 0, 1, 1. Okay. So what is the definition of, what is the output definition of decoder means? At a time, only one output is active. Output is active. Okay, for example, what you are trying to say that in the sense, I'm a user. Initially, what happened? I'm going to provide a 0 as an input combination. So in the output circuit, four outputs are there. So among the four output, what happened? Why not only it's enable? Suppose you are giving input as 0, 0. So that the enable how we are going to denote means 1. So now what is the meaning is I'm a user. I'm going to provide input as 0, 0. 0, 0, 0, 0 means what is the meaning there? So this is a binary representation. What is the respective decimal representation? The decimal representation also it's called as a 0. Am I correct? So what is the meaning is the output line why not is enabled. The rest of the outputs are disabled. That is the meaning is. That is the meaning. Okay. How the enable how we are going to denote means that is called as a 1. The rest of the cases we are putting 0. Suppose I'm a user, I'm going to provide the input as 0, 1. So what is the decimal representation of 0, 1? 1. What is the meaning is the output line y1 is enabled, the rest of the cases are disabled. Okay. Similarly for rest of the cases, 1, 0 is nothing but 2. So what is the meaning is the output line y2 is enabled, the rest of the components are disabled. That is the meaning. So what about 1, 1? There is a 3. So what is the meaning is y3 is enabled, the rest of the output lines are disabled. That is the meaning is. So that is a truth table of 2 by 4 decoder. Okay. Suppose they will ask you, you want to designing the circuit diagram for 2 by 4 decoder. How do you draw that? Okay, first, so this is the output, this is the input. Okay, how do you draw the circuit? You take the output based on that. What happens? You are going to form a Boolean expression. From the Boolean expression, make use of that. What happens? You are going to draw the circuit diagram. Okay, so first what happens? I am going to take first output y naught. Okay, here only what happened? The output is 1. So I'm going to take the rest of the input combination. What is the rest of the input combination? So x bar dot y bar. So what about y1? If we consider y1, here only the output equal to 1. Okay, you take the rest of the input combination x bar dot y. Similarly y2. So y2 is x dot y bar. What about y3? X, y. Okay. If you draw the circuit, there is a circuit diagram for 2 by 4 decoder. Okay. Okay. So this is a min term. How do you denote the min term? Small m. Okay. Okay. So do you have any queries regarding this?
No, sir.
Okay. So for that, what happened next? I'm going to draw the circuit diagram. For that, what happened? I'm going to draw the circuit diagram. So what are the input specification? So y naught equal to x bar y bar. Y1 is x bar y. Y2 is x dot y bar, and y3 is x dot y. Okay. How do you draw the circuit? Okay. How do you draw the circuit? Okay. Okay. So I'm taking x, I'm taking y. So now what happened? I'm going to implement the circuit. Okay. Okay. What is the first thing? X bar y bar. X bar y bar. Okay. So it's going to produce a min term. Okay. So for that, what happened? I'm going to add one AND gate. The output is y naught. What about next one? X bar y. Okay, it's going to generate output to y1. What about next case? X y bar. This is y2. What about the last case? X and then y. Okay, this is y3. So x bar x bar y, and then x y bar. This is x dot y. Okay, do you have any queries in the circuit diagram?
No, sir.
Okay. So next what I am going to do, I am going to take 2 by 4 decoder with the enabling. Okay. Uh, such cases, how the circuit diagram should be appear. For example, what I am going to do, I am going to take 2 by 4 decoder with the enabling. With enabling. So already I said, if you take the enable input, two types of different combinations are available. One is active high input. Another one is active low input. Okay. Let's see one by one. First time what happened? I'm going to take active high input, active high input. Okay, what is the meaning? That same circuit, similar to previous one, but it had extra one input value that is called as a enable. Okay, it take 2-bit variable as an input, and then it going to generate output as y0, y1, y2, and then y3. Okay, along with that, what happened? We are going to add extra one more parameter that is called as a e. Okay, so in this is called as a specification for 2x4 decoder with active high input. This is called as a specification. Okay, this is called as a specification. Okay, here what did happen? So whenever input value equal to 1, what happened? It enabled the circuit. What happened? Whenever the input value equal to 1, what happened? It going to enable the circuit. Suppose the input value equal to 0, no operation. So what is the meaning that it will switch off that decoder. Okay. Okay. For that, how do you draw the truth table? Okay. How do you draw the truth table? Okay. So okay, my input is x, y. Along with that, what happen? I'm going to add enable input. Okay. What happen? What are the output it going to generate? Y0, y1, y2, and then y3. Okay, it is a two variable function. How many number of combinations are available? 4, 0, 1, 1, 0, 1, 1. Okay, so when it's going to generate the output means whenever the enable bit value equal to 1, then only what happen? It's going to generate the first output. Okay, my input is 0, 0, my input is 0, 0, and then e equal to 1 means what is the meaning that I am going to turn on my decoder. Equal to 1 means what is the meaning that I'm going to turn on my decoder. So 0, 0 means what? 0. So what is the meaning that the output line, 4 outputs are there. Among them, what happen? It's going to enable. Why not alone? That is the meaning. Okay, next, again I'm going to turn on my circuit, and after that, what happen? I'm going to provide input as 0, 1. So what it's going to do? Okay, y1 line is alone active. Okay, similarly. Third case, Y2 line only enable, and then Y3 line is enable. Suppose, sir, instead of 1, sir, what I'm going to do, I'm going to provide input as 0. Same combination, 0, 1, 1, 0, 1, 1. So what happened? I'm going to provide E as 0. What happened? So whenever you are going to provide E equal to 0 means you turn off your decoder. So what is the meaning that it going to disable your circuit? It does not. Such cases, what happen? It does not enable any output combination. Okay. Similarly, here also, what happen? Does not enable any output combination. Okay. Does not enable any output combination. That can be denoted as a like that. Okay. My enable is 0. My enable is 0. Okay, and then after that, what happened? I'm going to provide don't care condition. So what is the meaning of don't care condition means? So whatever may be input combination. So whatever it may be means, this is a one input combination, this is another input, this is the third input, this is a fourth input. So whatever input combination, what happened? It does not enable any one of the output line. Okay, that is the meaning is. So instead of that, what happened? I'm going to write the table like that. I'm going to write the table like that. So I'm going to, my enable line is a 0. The input combination, whatever it may be, okay, the output is 0. the output is 0. Okay, this is a truth table for active high input. So do you have any queries? Do you have any queries?
No, sir.
Okay, what is the meaning of don't care condition means? So this is a don't care condition. What is the meaning? What is the meaning is I don't know I know that either x value is either 0 or 1, but I don't know specifically what is the value of x and y. I am correct. That condition we call it as a don't care condition. Here, what it try to represent that means your input combination, whatever it may be, 0, 0, 0, 1, 1, 0, 1, 1. If any combination, what happen? It going to generate the output as 0. That is a mean. So for that, what happen? I'm going to draw the circuit diagram. Okay. So for that, what happen? I'm going to draw the circuit diagram. Okay. In order to draw the circuit diagram, what happened? First of all, you needed the truth table. Okay. So how do you draw the truth table? Okay, already we have seen 0, 1, 1. This is a 1, 1, 1, 1, 0, sorry. 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Okay, how do you draw the circuit? First, you draw the circuit for Y naught. Y naught, what is the Y naught? Y naught is here only the input output value equal to 1. So you take the respective input condition. Okay, how it should be appear E x bar y bar. So what about y1? So E x bar y. So what about y2? E x dot y bar. What about y3? The y3 is E dot x dot y. Okay. So now you should draw the circuit diagram. How do you draw that? Okay. How do you draw the circuit diagram? Okay. One line is enable. That is a E. So another input is x. Another input is x. What about next case? The another input is y. Okay, another input is y. Okay, should draw the circuit diagram. Okay, E x bar y bar x bar y bar. Okay, this is x bar y bar. This is y naught. What about next case? E x bar y x bar y x bar y. This is a y1. What about next case? E x x and then y bar. Okay, this is y2. So what about the last case? Enable x and then y. Okay, this is a y3. Okay, whenever the enable value equal to 1. Okay, do you have any queries?
No, sir.
Similarly, what happen? I'm going to take I'm going to take active input is low. That cases, how your decoder should be appear. So now what I'm going to do, I'm going to take 2 by 4 decoder, 2 by 4 decoder using active low input. Okay, what is the meaning of active low input? So already we have seen. So active low in the sense what happened? This is a decoder. It's going to take input as a two variable, namely called x, y. Okay, how do you denote that? Okay, that is denoted as 2 by 4. 2 is the input and 4 is the output. Okay, it's going to generate output as y0, y1, y2, and then y3. So here what happened? I'm going to provide the enable input. Along with that, what happened? I'm going to add the bubbles. Okay, along with that, I'm going to add the bubbles. The bubbles otherwise called as an inverter. Inverter. Okay, already you know that what is the meaning of inverters. Okay, suppose I'm going to provide input as a zero in the sense what happened? Okay, it's going to make a complement. Okay, how we are going to denote complement like that? So meaning is one. Suppose I'm going to provide input as a one, what happened? It's going to take the complement. What is the complement value? Zero. Okay, that is the functionality of inverters. Okay, so for that, what happened? You are going to draw the truth table. This is a specification of 2 by 4 decoder using active low input. Okay, this is called as a specification. Okay, this is called as a specification. So for that, what happened? You are going to draw the truth table. Okay, truth table. Okay, so one input is x, another input is y, and then along with it, what happened? I'm going to take enable as a one more input. Okay, what is the meaning is, so already I said, whenever suppose if we consider active low input, the enable value is 0 means what happened? Okay, they enable the circuit. What happened? Enable the circuit. Suppose my input is 1. What happened? Okay, no operation. Okay, no operation. No operation. Okay, so this is a two variable function. Okay, how many number of input combinations are available? 4. 0, 0, 0, 1, 1, 0, 1. Okay, suppose I'm a user, I'm going to providing input combination is a 0, along with that what happen, I'm going to feed enable bit value equal to 0. If 0 in the sense what happen? In 0 in the sense what happen? Okay, what is the meaning is 0, 0, what is the binary decimal representation of 0, 0, 0. So what is the meaning is the output line is associated with the four lines. Among them, what happen? It going to enable why not alone? The rest of the components are disabled. That is the meaning is. Okay. Similarly, what happen? I'm going to take input combination as a 0, 1. There is nothing but 1. That case is what happen? It's going to enable output line y1 alone. Okay. Um, Similarly for rest of the cases. Okay. Okay. Next, suppose I'm a user. I'm going to provide input as 1. So this is a two variable function, means four combinations are available. Okay, four combinations are available. So in these cases, what happened? Already we have seen that this is an active low input circuit. Suppose your enable input is one in the sense what happened? It does not generate any output for any different type of combination of input. Already we had discussed that. So that can be I'm going to represent it as a like that. So what is the meaning is E, X, Y. These are the output Y naught, Y1, Y2, and Y3. Okay, suppose your enable value equal to 1 in the sense your input combination, whatever it may be. Okay, that is called as a don't care condition. The input combination, whatever it may be, what happened? The output, what happened? It does not generate, it does not enable any output component. That is a meaning. That is a meaning. So that can be represented as a like that. Okay, suppose your enable input is 1, and then input combination, whatever it may be. Okay, whatever it may be in the sense 0, 0, 0, 1, 1, 0, 1, 1, what happened? The output line, what happened? All the output are 0. What is the meaning is, it does not enable any input. Okay, so do you have any queries? So this is a truth table for active low input. Okay, do you have any queries?
No, sir.
Okay. So now what is the next case? For that you want to draw the circuit diagram. Okay, how do you draw that? How do you draw that? Okay, how do you draw the circuit diagram? Okay, this is a truth table. Okay, was 0, 0, 0, 0, 0, 0, 0, 1, 1, 0, 1, 1. The next case. Okay, what are the output? 0, 1, 2, 3. Okay, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Okay, okay. How do you draw the circuit? Okay, it associated with the three input, namely called E, X, Y. Okay, okay, okay. So what is the first output? The first output is how do you draw that? Okay, I'm going to take the first output. Why not? How we are going to generate? Okay, how you are going to generate y naught is okay e dash okay e dash x dash y dash. What about y1? E dash x dash y. What about y2? Y2 is e dash x y bar. What about y3? Y3 is e dash x y. Okay, that is a circuit. So now you are going to implement. So okay, then now the e value equal to 0. Okay, what are e dash x dash and then y dash. Okay, what about next e dash x dash and then y. Okay, this is a y naught, this is a y1. What about next case e dash x and then y bar, y bar. This is a y2. What about y3? Y3 is e dash x and then y. Okay, that is a y3. Okay, do you have any queries? Do you have any queries? Okay. Any absent is there? Okay, thank you so much. If you had any queries, to be stay on online. Otherwise, we can wind up the session. Okay, thank you.